All right, so what do we do here? We got to remind ourselves, this goes back a little bit to like the beginning of the year when we talked about finding inverses. What's our strategy for finding an inverse of a relation? In this case, a function. So what do we do? Yes, sir.
Switch X and Y.
Okay, good. So we had a pretty easy formula for this, right? We had a little procedure. So we would just say, first thing we would do is we would write it in terms of y, right? So we take this function and we change the f of x to a y. I'm going to include the domain on this too. Okay, so then the recipe for finding an inverse is just to switch x and y. And remember, that's what it means. Inverse relations, when we find the inverse of a relation, literally all we are doing is we're exchanging the domain and the range. So we really are just changing x and y. So then we'll flip these around. I'm going to put this guy over here and that guy over there because we're going to be solving for y. So 7/9 y squared plus 1 equals x. Now what's that going to do to our domain? Instead of x being greater than or equal to 0, what's that going to become? Y. Okay. Good, because once again we exchanged the domain and the range. So for the original function, the restriction or the constraint was that the domain has to be non-negative. That means that for the inverse, the range has to be non-negative. Okay? And then what do we do from there?
Solve.
Just solve, right? Just isolate y. So what do we do to isolate y here then? In order, what are the steps? So subtract 1, good. Then what? Oops, I got a 7/9 there, don't I? Then what?
Times by the reciprocal.
Yeah, multiply by the reciprocal. Multiply both sides through by 9/7. So then I'd get y squared equals, is this right?
No.
What's wrong with that?
You didn't distribute the 9/7.
Got to distribute the 9/7. Or I've got to write the x minus 1 in parentheses, right? Either or. Okay, so last step.
Square root.
Square root. Okay, so what's that give me then? That gives me y equals plus or minus, good, plus or minus the square root of 9/7 times the quantity x minus 1.
Is the plus or minus a given?
Well, what do you mean, is it a given?
But since y is supposed to be greater than or equal to
You're right,
0,
yeah.
it's supposed to be.
You're right, so we're only going to keep one of those. But no, you have to write it, because if we just walked up and saw this, and it didn't have the plus or minus there, how would we know it's supposed to be there, right? See what I'm saying? So it has to be there, because it's actually, and we're going to talk more about that in a second. But yeah, it's got to be there. However, if we take into account what our range has to be, right? And I didn't write that each time, but that needs to be, that needs to be reflected down here in our answer, doesn't it? Really, after each row, I probably should write that again. Okay, because it is included as part of the function. If y has to be greater than or equal to 0, well, we know that the output of a square root is always positive, isn't it? Right? Or non-negative, could be 0. So I would just cross out the negative, right? And so our answer would just be positive, the square root of 9/7 times x minus 1. I don't care if you simplify the radicals on these. I don't want you to spend the time on that. You know how to do that. But that would just be our answer. Okay? Questions? All right. So let's just, let me make sure that what I just told you is true. So if I put this in as, yeah, it'd be fine. It'd be fine either way. You could prove it to you and myself. So if I just write this as square root of 9/7 times Yeah, I got credit. Okay. Alrighty. So no big deal. I'm not even gonna do another one of those. You guys can do those. So let's move on. I want to show you, while we're at it here, I'm gonna show you something else I've got going. I spent a ton of time on this the last couple days. If you go to, this is the assignment for 10.1. In an effort to try to make these things a little shorter. Okay, when you go to the assignments, here's what you're going to see. Like on 10.1, there's only 8 questions. So instead of doing this over the course of probably what previously I would have done, like 2 or 3 assignments for this one, I'm just doing one. And look what this does. It says write the inverse of at least one quadratic function, and what does this look like if I'm a student? Do you guys see it that way? So this is the 10.1. Oh, hang on. So Unit 4 practice, this is the stuff we're talking about is 10.1, by the way. We skipped 8 and 9. So if I go to this, yeah, there's what it looks like. Okay, good. So this is what it looks like from your perspective. So it says write the inverse of at least one quadratic function and one cubic function, meaning, you know, in most cases it's going to work out that for sure you're going to see that. But in this case, look, these were all, you didn't get a quadratic one in there, right? So what would you do? Well, then either do a couple of these, or on this one right here, just put in a wrong answer and just reload it until you get one that's, there you go, that's a quadratic. So I want you to do one of each. But I'm really paring down what you have to do. So I gave you kind of the upper level questions, and if you can do those, you're fine. But if you can't, if you're having trouble with those, I put at the top, I went through this process of building, if you look here under Unit 4 Ungraded Practice, all of these are assignments that I'm going to send you to, or you can send yourself to if you need some additional practice, right? So if we go back to this assignment, for more ungraded practice, go to here, to that ungraded practice, and it opens it up. And then I've broken them down by level. So there's like level 1, level 2, and level 3 problems on this. And so if you want to get some additional practice, you could go, say I want to try a level 2 problem maybe. So I go to a level 2 problem, and there are the level 2 problems. And I can just keep trying those if I want to get some introductory practice, right? Or when you're studying for the test, instead of doing practice tests now, I'm just going to say, this test will have, from this standard, it's going to have, you got to be aware how to do a level 3 problem. From this one, you got to be, see what I'm saying? So you can just go in and practice as you need to. The idea being, I'd really like you guys to look at this more like a college class. I want you to kind of get in that mind frame where the practice is really just, just do as much as you need to get ready so you know the material. Does that make sense? Okay, so you'll just do that. So on each one of these blocks of problems, where they're different types of problems, I'm going to give you the minimal amount. Like I say, if you can do them, fine. Yeah, I think you're okay. Probably don't need to go back and look at anything else. But if you do, like if I scoot up to this block, these are the ones where this is kind of cool. Stuff we're going to talk about today. If this isn't making sense, then go back and try some easier ones. Try it step by step. When I build these problems, I always go through and I try to build levels where, like, the lower level problems would have fewer steps involved in solving them, so you can kind of focus on just each individual step more, stuff like that. I put a lot of thought into how to break them down by difficulty. So, is that going to work, you think? Is that okay? I thought that would be a way to maybe reduce the homework load and still make everything available. All right, so moving on. Let's try one of these. How are these different? I can't remember. Oh yeah, these have domains and ranges, right? So let's talk about something like this guy right here. This really isn't very different from the last one. Okay, so what about this here? We're supposed to, I mean, finding the inverse is no big deal, right? Well, what would the steps be to get this inverse? I mean, we already talked about switching the x and y, right? So write this in terms of y. What are the steps in order to get x by itself? Or sorry, to get y by itself when I switch it? Sorry, we're gonna end up with 6y cubed plus 9 equals x. Matthew, what would I do to get the y by itself? First I would, well, no, we can do first.
We're gonna subtract.
Subtract 9, good.
And then we would divide.
Divide by 6, good. And then,
And then we square root it.
well,
Or cube it.
cube root it, right. Okay, good. So then, and remember with the cube root, do we have to do the plus or minus?
No.
No, we don't. Good. So then we'd end up with what? Y equals the cube root of, what's that going to be? X minus 9 all over 6. Everybody by that? Okay. So then here's the part I want to focus on though. I want you to answer what's the domain of the inverse function, and then number 3, in order for the original function to be invertible, right? So for it to be, for the function to be, have a 1-to-1 correspondence with the inverse, what would its domain be? So let's look at this in terms of a graph. So the original function, this is a cube root function, 6x cubed plus 9, so it's going to look something like this. I'm not going to draw this thing exactly, but the original function would look something like that. Okay. What's the inverse going to look like? How do you find the graph of an inverse? How are the graphs of two inverses related? A function and its inverse. What kind of symmetry do they have? You remember?
You reverse the pairing of relation.
Okay, so you're both, okay, good. So they reflected over the line y equals x, but what was our recipe for doing that? Katie, there's an easier way to do it. That's what you're saying.
So you're like, if the point is -4, 2, then it's -2, -4.
Right, okay, good. So all the points, and that means they're all gonna get reflected over this line, right? And that's what you were saying, Kirk, that the line y equals x is the line of reflection. So we're just gonna literally take this thing and reflect it over. Do you remember the trick I showed you guys for that earlier in the year that makes, it's a little hard to reflect something over a diagonal line, but you can do it in 2 easier steps?
I'll rotate it.
Good. You rotate it counterclockwise 90 degrees and then reflect over the y-axis, right? So we could do this. We could take this thing and reflect and rotate the whole plane this way. So that point would go to there, right? And then it would go kind of like that first. Then we'll take that and reflect it over the y-axis, right? To get this. I have a hard time with this here, so that's going to go like that. Everybody agree? Okay, so then this is our new function. That's the inverse, isn't it? This is f, and this is f inverse, right? Are there any problems with f inverse here? Does it violate the vertical line test in any place?
No.
Doesn't, does it? How could we have predicted that? And this is, we haven't talked about this for a long time. See if you can remember. How could we have predicted on the blue function that its inverse was going to be fine? It was also going to be a function. Hold that thought. Let's compare it to, well, this will help you answer the question. Let's compare it to this one. How about if we say the original function f of x equals, just call it x squared. Let's make it a little harder. Let's make it x squared plus 3. Okay. Actually, we'll make it x squared plus 4. Okay, what's the inverse of that one going to be?
Y equals the square root of 4.
Okay, so we're going to get the inverse is, if I make that a y and then I flip x and y and solve, so that's a y and that's an x and that's a y. Would you agree I'm just going to get plus or minus the square root of x minus 4? Everybody agree? Okay. I got a plus or minus there. Let's see if we can get to the bottom of that. Let's graph the blue function first. The blue function just looks like this. Okay. So would you guys agree if I reflect that over this line? If I rotate it and then do that, I'm going to end up with something like that. Okay, what's wrong with the red relation? Yeah, I've got problems there. It's violating the vertical line test, isn't it, right? And so that's why the math gods in their infinite wisdom, they added that plus or minus there, didn't they, right? Because we've got to split this thing into two separate pieces. Now, if I consider only the positive square root, it's fine, right? If I consider only the negative square root, it's fine by itself, right? So either one of those independently are okay. And so that's why we get that plus or minus there, right? It's actually two separate functions that we have to break this thing into, right? Okay, but then what does that imply? Let's just say that we're going to keep the principal square root as the positive one, right? So that's the one that we typically want to keep. So let's say that the positive one is going to be the green one. If that's the part that we're keeping, so we can make this into a function, I've got two questions for you. First of all, how could we have seen that we were going to have a mistake before we even did the rotation? Say it again. Okay, good. On the original function, it is a function because it passes the vertical line test, right? But we can see that there are, this is a many-to-one function, isn't it? Because for different x values, we get back the same y value. Everybody agree? For example, if we take this point right here, take this point right here, and that point right there, they have the same y value, but different x values, right? So for the original blue function, multiple x values could map to the same y value, which is okay. Right? Remember, we call that a many-to-one. Down here, this is a one-to-many. Down here, if I have a single x value, that maps to multiple y values, which is a no-no, right? That's violating the vertical line test. Okay? But what Kirk's saying is, we could have predicted that the inverse was going to violate the vertical line test because the original function violated the horizontal line test, right? Which doesn't mean it's a non-function. It's still a function. It just means that it's not a one-to-one function, right? If we go back to this previous picture, this blue function is one-to-one, meaning there's only going to be one x value mapped to each y value, right? There's no place where we're going to get something like this going on where multiple x values map to the same y value, right? Okay? And think about it this way. If we were to reflect the horizontal line that we're using to apply the horizontal line test to the blue function, if we were to reflect that over the line y equals x, what would it end up being? It would be a vertical line, isn't it? Right? Because we're going to rotate this thing so it's going to look like this, and then we're going to flip it over here, and it becomes that, doesn't it? Right? Does that make sense? Okay, so question 2 then. If we want to rewrite this function so we're only going to keep the principal or positive square root, what do we have to do to our original function so that it corresponds to only the positive part of the square root, only the positive square root, right? Just that top one, which is a function by itself. In other words, to make the original function one-to-one instead of many-to-one, what do you think we'd have to do? We'd have to restrict the domain, wouldn't we? Right? We'd have to restrict the domain to what values?
0.
Yeah, okay, all values greater than or equal to 0. So we're going to lose this part back here, aren't we? Which is okay, because then this, this part right here is going to map to that part right there, isn't it? Right? And it's now 1 to 1. Another way of saying that is to make the original function invertible. So we can take, to invert something means to take the inverse and have that be a function. In order to make that true, we would just have to restrict the domain. So what would the domain of the original function be? Now I want you to kind of think about this. Do you want to put that away, please? Let's think about this in terms of kind of a process other than having to graph it, right? So what would, Katie already told us, the original domain would just be x has to be greater than or equal to 0, right? What's the domain of this function? Of the inverse function? What's the domain going to be? Can you tell me? What do you think?
Y is greater than or equal to 0?
No, it's not going to be greater than or equal to 0. It is greater than 0, but we can be more restrictive than that.
Whatever that point is.
Yeah, wherever that point is right there, right? Wherever that point is right there. Now let's think about that. Remember what we said about functions and inverses, right? When we take the inverse, we're swapping the domain and the range, right? So if we want to know what the domain of this function is going to be, I could answer that question in a different way by asking what the range of this function is going to be, right? Everybody agree? So what is the range of this function, of my original quadratic function? Where's the vertex on the original function? It's in a form where we can tell, isn't it? It's actually written in the form. It's written in the form f of x or y equals a times x minus h squared plus k, isn't it? What's h? Say it again. Not h. What's h? H is the x coordinate of the vertex. What's h? 0. And we can tell because what's being subtracted from x, this is the same thing as saying x minus 0 squared, isn't it? Plus 4. Now what's k? 4. There you go. Right? K is 4. K is the constant that's being added to the function, right? So the coordinates of the vertex here are 0, 4. And what's the value of a? A is 1. It's positive. What's true for a positive value of a for a parabola? What's it do? Does it open up or down? It's going to open up, right? Good. If it's negative, it opens down. So if the vertex has a y value of 4 and it opens up, what's the domain of the blue function? Greater than or equal to 4. Very good. Okay, so we get y is greater than or equal to 4. What does that mean the domain must be over here? Yeah, because the domain becomes the range. We're swapping x and y, aren't we? Right? So that means over here our domain is going to become x is greater than or equal to 4. Should have made that red. What's our range going to be then? Y is greater than or equal to 1. Sure. Everybody see that? Okay. Now the math gods are clever. We could have done this in a different way. We could have done this just algebraically too. And this is a way we'll do this a lot in calculus, for example. If we just look at this function up here, remind me, what are the two fundamental no-nos for real numbers? We can't divide by 0, right? That's a common one. There's another one too. Remember the other one? We can't do something else. We haven't talked about this one as much, but we're going to start talking about it a lot in the next few days. You can't divide by 0, and you can't take an even root of a negative. Because if we do, we're going to get i's, right? Everybody agree? The most common even root being a square root, right? Like in this case. So we can't take a square root of a negative. So let's look at this in terms of where's the red flag going to be on this function? I've got this function equals the square root of x minus 4. Right? right? I always talk about this in calculus as being, kind of identify a bubble. What's the part of the function that could violate one of those rules? Well, isn't it the part inside the radical right there? Whatever's in the purple bubble has to be non-negative, right? Everybody agree? So we can just say purple bubble has to be greater than or equal to 0, right? Without even worrying about what's in there. The argument of the radical, whatever's inside, has to be, it can't be negative, right? So, well, what's in there? Well, what's actually in there is x minus 4, right? How do we solve that inequality? We had a lot of practice with that. Pretty simple. Add 4 to both sides, right? So if I solve this, I end up getting x is greater than or equal to 4. What do you know? That's my domain, either way. Make sense? Okay? So try one of these then. How are we doing for time? We're okay. Try one of these from scratch now. I want you to. So let's try, we'll try that one. This is a pretty easy one. If it's cubic, you guys already answered this one actually, I think. If I go back here, what was the answer? There's our, you did the only hard work really was finding what the inverse function was. But look at the blue function and the red function. It's an odd function. Are either one of those domains restricted in any way? No. So what's the answer going to be? The function was, you remember what it was? I already forgot. It was, cube root, whoops. So the inverse is the cube root of x minus 9, okay. X minus 9 all over something, right?
6.
Okay. All over 6. Make that a cube root. Okay, like that, good. What's the domain if I'm going to write it using inequality notation? It's unrestricted, isn't it? So how do I say that with an inequality? Okay, so negative. So x is what then? Good. Okay, greater than negative infinity and less than infinity. Okay, and what's the domain of the, that's the domain of the inverse. What's the domain of the function? Same thing.
I use this interval notation.
What's that?
Yeah,
Oh.
I know it's interval notation.
Oh, it says oh, thank you. I didn't even read my own question. So interval notation, that's right. I wanted to get a little practice with both. So how would I change that to interval notation? Okay, what am I going to use, brackets or parentheses? I got to use parentheses. How come?
It's not equal to or.
Good, because you can't, infinity is not a number. You can never equal it. Good.
That's right.
Okay. Now redo, so I would have to, I don't want to redo it. But anyway, that's right, that's the right answer. Okay. What about this guy right there? Let's try that one. Try that one on your own. If you can do that one, you can do any of these. That's pretty tough. Try that. Okay, let's have, phones ought to be away. Phones ought to be away. I don't really want to see you guys eat. So, just because we're running out of time here, let's take a look. So if we look at let's answer part 3 first. Actually, no, let's not. Let's not. Never mind. So what do we do to answer part 1? To find the inverse. Switch x and y. Okay, so what are the steps going to be then? If I switch x and y, I'm going to end up with 8/5 y squared plus 8/3 equals x. So first I'm going to subtract 8/3. Then what? Okay, multiply by the reciprocal. Okay. Okay, what do you think? Should I distribute that? I mean, I could in this case. Why might I distribute it in this case? Yeah, I'm gonna get some cancellation on it, right? I mean, it's, I think it'd probably be okay either way, honestly, but what if we distribute? Then we're gonna end up getting 5/8 x minus, what's that gonna be when I distribute here? What's 5/8 times 8/3? 5/3. Okay, and then I just square root both sides, right? So y would equal plus or minus the square root of 5/8 x minus 8/3. But if we want this to be a function, I can't have the plus or minus, right? I'm going to discard the minus and keep the plus. Okay, so then what does that make the domain of the inverse function? So there's the answer to part 1, right? So what's the domain going to be? How could I do this one? How could I find the domain? A couple ways. How could I find it directly? What inequality could I set up here? Maybe that helps. What do you think, Matthew?
5/8 x minus 8/3 is greater than or equal to 0.
Good. Whatever's the argument of the function, whatever's in the bubble has to be non-negative, right? So all this stuff has to be non-negative because I can't have a negative number inside the radical. And then I just solved that. What are the 2 steps? In order, what do I do? To isolate x, add 8/3. Remember, oh yeah, 5/3. Oops, you're right. You're right. Good. 5/3. Okay, and remember the algebra of inequalities is exactly the same as the algebra of equations, with what's the only exception we have to worry about? If I multiply or divide, okay, then I flip this sign of the inequality, but I'm not, am I? Right? I'm multiplying both sides by positive 8/5, and so I just get x is greater than or equal to 8/3, greater than or equal to 8/3, right? Okay, back to this one real quick. How could I find out what the domain of this is going to be? Think about this in terms of a parabola. Where's the vertex going to be? What are the coordinates of the vertex? H is 0, right? Because I'm not subtracting anything from H. And K is 8/3, right? So then I'm just going to, if I'm only going to take that half of the parabola, if the coordinates of the vertex are at 0, it doesn't even really matter, but 8/3, what's the domain going to be? This can be everything to the right of the vertex, right?
So 0.
0, greater than or equal to 0? Everybody see that? Okay. All right, that'll get you going.